All right, so a function is defined by h, is that, right? H of x. So I'll just write it as h of x is equal to 4x minus 7 over 2x minus 3. Okay, and we're asked to find the inverse. We're asked to find the inverse of the function. So what's the inverse of the function? The way we do this is we replace, well, first I'll have to replace h of x with y. Then the next thing to do is I will switch x and y, right? So I'll switch x and y. I would have x is equal to 4y minus 7 over 2y minus 3. Then the final thing to do now is I need to make y subject of the formula, right? Because this y here, now that I've switched it, this y here represents the inverse function. So I'll cross multiply. I would have 2y minus 3 multiplied by x is equal to 4y minus 7. I'll have 2yx minus 3x is equal to 4y minus 7. Okay, so collect like terms. I'll move 4y over to the left hand side and 3y and minus 3x over to the right hand side. So I would have 2yx minus 4y is equal to 3x minus 7. If I factor out my y, I would have y bracket 2y minus 4 2x minus 4 is equal to 3x minus 7. So I'll end up with y is equal to 3x minus 7 over 2x minus 4. Okay, so the correct option is option D. Okay, so well, the next question that pops up, just speaking a bit about what or why this is here, right? Okay, so the idea of these restrictions, you find them in rational functions that are like fractions, and the idea is that your denominator cannot be equal to 0. If your denominator is equal to 0, then the entire system becomes undefined, right? So I need to say, oh, my function cannot have the value that makes the denominator 0. So in this case, it is that x cannot be equal to whatever makes this guy here equal to 0, right? So let me solve for that. I have 2x minus 3 is equal to 0. I'll end up with x is equal to 3 over 2. So that means that this value, my denominator here, becomes 0, which is why I have to append that x must never equal 3 over 2. Same thing here. I cannot allow my denominator to be 0, right? So I would say 2x minus 4 must never equal 0. So that means that 2x must never equal 4, or x must never equal 2, right? When I divide both sides by 2. Yeah, so the correct option for this is D. Okay, now number 2 says a function is defined by that and that. Find the inverse function where x is equal to half. Okay, so it's the exact same question that we had there, right? It's just the baby brother. So if you're joining the video at this point, you want to go back and see how we solve the inverse function, just so you can just skip back, if you maybe like 3 minutes, and you'll see that, and then you can now come down to watch this. But we already have that the inverse function is option D. We have that the inverse function is h inverse of x is equal to 3x minus 7 over 2x minus 4, where x is not equal to 2. So well, h inverse of half, I'll just plug in half. H inverse of half, yes, positive half would be 3 times half minus 7 over 2 times half minus 4. So this would be, well, 1.5 minus 7 over 1 minus 4. This would be, I think, negative 5.5. All right, negative 5.5 over negative 3. Okay, so from the way the answers are presented, right, so let me switch it to fraction. So that's basically saying, let me do the math. That's negative 11 over 2. 5.5 is 11 over 2. Then divided by minus 3, right? So divided by minus 3, that would be negative 11 over 2 times times 1 over minus 3, which will become 11, negative 11 over negative 6, which is just 11 over 6. Okay, so the correct option for this one here is D. Okay, let's take question 3. Question 3 says, a function defined by this such that f of 3 is 6 and f of 1 is minus 2. F of 3 is 6 and f of 1 is minus 2. Okay, so what we'll do here is we're trying to solve for the variables, right? So I'll just solve this out. All right, I'll solve this out. And so let's say this is saying that when x is 3, y is 6, and when x is 1, y is minus 2. That's the meaning of this line of information here. All right, so the function is y is equal to x squared plus px plus q. So let's plug in. I would have 6 is equal to 3 squared plus 3p plus q. I would have 6 is equal to 9 plus 3p plus q, or 3p plus q is equal to negative 3. So I got that from plugging in the first scenario. Plug in the second scenario, I would have minus 2 is equal to 1 squared plus p plus q. All right, so I would have well, p plus q is also equal to negative 3. So let me just check my math a moment. X is 3, y is 6. Check. X is 1, y is minus 2. Check. Plug it in. Y, which is 6, is equal to 3 squared, which is 9, plus 3p plus q. Yes. 9 minus 3. 10 minus 6 minus 9 minus 3. If I plug in, if I drop minus 2 in for y, minus 2 would be 1 squared plus 1p plus q. Okay, so it's always a great idea to check your math, right? Because if you wait till the end, it might become just more annoying. Okay, so I have 3p plus q is equal to minus 3. This is from the first equation here. And I have p plus q is equal to minus 3. So if I can eliminate, I can subtract, both of them, right? I'll basically end up with p, with 2p is equal to 0, and so that means p is 0, right? So I'm getting p as 0. And so if I solve for q, q gives me minus 3. So I got p as 0 and q as minus 3. So the correct answer is not there. Correct answer is not in the options. The correct answer is minus 3. Okay, so question 4 is saying it gives us a function. It says y is equal to x plus 2 over x minus 3, and it says to find the inverse of y. All right, so the first thing you do is you switch x and y. You switch x and y. If I do that, I would have a new function. I'll have x is equal to y plus 2 over y minus 3. Right, so this already, the y here already represents the inverse, right? But we need to rewrite our function in such a manner that is a function of, like, y is the subject of the formula. All right, so first now cross multiply. I would have x bracket y minus 3 is equal to y plus 2. Then xy minus 3x is equal to y plus 2. Then I'll collect like terms because I'm trying to isolate y, so I'll collect like terms. So I would say xy minus y is equal to 3x plus 2. Right, so I moved y over to the left hand side and minus 3x over to the right hand side, and now factor out y. Okay, and my final answer would be y is equal to, because now I can divide both sides by x minus 1, right? So y is equal to 3x plus 2 over over x minus 1. Okay, so that's option C. That's option C. All right, so the function f is defined on the set of R, which is all real numbers, as y is equal to x plus 3 over x minus 1. Okay, so the function, this question is actually supposed to be saying find f inverse, right? So we'll correct that. So that's saying find f inverse. All right, so we'll have so the first step you do to find the inverse function is you switch x and y, right? So I will have x is equal to y plus 3 over y minus 1. Okay, so the next thing now is we need to figure out a way to make y symmetric of the formula. Simple enough, I'll cross multiply. I would have x bracket y minus 1 is equal to y plus 3. So xy minus x is equal to y plus 3. I'll collect like terms, put all the y's in one space. So I will have xy minus y is equal to 3 plus x. Now I can factor out y. Y bracket x minus 1 is equal to 3 plus x, and I can divide both sides by x minus 1. I will get y is equal to 3 plus x over x minus 1. So 3 plus x over x minus 1. That's option A. 3 plus x over x minus 1. That's option A. But there's an issue with the option here, right? Because the restriction is supposed to be x cannot be equal to 1. All right. So if you've watched the other videos, I've explained that you get your restriction by finding where your denominator would be 0, because normally, generally your denominator can never be allowed to equal 0, because at that point the entire system, blows up. It gets undefined. So the correct part to this here should have been x cannot be equal to 1. All right. So there's this. I'm sure by the time you're watching the video, would have corrected that also. All right, so let's take question 6. Question 6 says find the domain of that, where x is set of all real numbers. Okay, so for this function, right, the only issue you have in the domain is where x is, your denominator will be 0. So your domain represents all the possible values of x that would work, right? And for a rational function, all values of x would work. The only issues you would have is where your denominator is 0. All right, so and where 3 minus x would be 0, the function gets undefined, and at that point x is going to be equal to 3. So the issue is x can be any number. All right, your domain is saying x can be any value to us, all right, such that x must not be allowed to equal positive 3. That's where you have an issue. So that's option D. All right, number 7. All right, number 7 says find the domain of this. Find the domain of this function. All right. Okay, so we have two restrictions. Restriction 1 is that your denominator cannot be allowed to equal 0. All right, your denominator cannot be allowed to equal 0. So by that, if I have square root of 9x squared plus 1, I already have an issue that this cannot be equal to 0. That means that 3x plus 1 must not be equal to 0. All right, so it cannot be allowed to equal to 0. That means that 3x must not equal -1 or x must not equal -1/3. So that's the first restriction. The other restriction we have is that whatever is under the square root sign cannot be less than 0. Whatever we have under the square root sign cannot be less than 0. Okay, of which a square root function only gives you positive values, right? We don't use the negative values in the square root function. Okay, good. So 3x squared, if you square x, you only have a positive answer. So yeah, so that doesn't affect that. So the only issue we have is that x itself must not be allowed to be less than, and must not be allowed to equal -1/3. All right, so there's obviously another issue with the question. The correct answer is probably supposed to be B, probably. And so by the time you're watching this again, you know, this would have been -1/3. The issue is x cannot be allowed to be equal to -1/3. That's question 7. All right, so let's go on to question 8. Okay, so question 8 says, if f of x is that and g of x is that, where x is set of all real numbers, find g of f. All right, so when you hear g of f, it means put f inside g. All right, another way to represent this would be to say, I can represent this as g of f of x like this. All right, so what's g of x? G of x is equal to x plus 1. So g of f of x would be, so in place of x, I'll put f of x, right? So that'll be f of x plus 1, which would be 2x squared minus 3 plus 1, which is 2x squared minus 2. All right, so if you look at the option, you know, you might think the correct answer is not there, but notice that if you factor out 2 here, you end up with option A as is written in my own, right, you end up with option A. So that's the correct answer. So that's for question 8. Let's take 9. All right, 9 is saying, given this, find the f inverse of that. Okay, good. So find the inverse function. First of all, I'll write this as y is equal to x plus 1/2. Next, we switch x and y, right? So x becomes equal to y plus 1/2. And then now we'll make y squared from the formula. So we'll have 2x is equal to y plus 1. Y is equal to 2x minus 1. Yes, y is equal to 2x minus 1. So that's my f inverse. F inverse function, f inverse of x is 2x minus 1. So if I plug in -2, so f inverse of -2 would be 2 bracket -2 minus 1, that's -4 minus 1, which is -5. All right, so the answer is -5. That's option B for question 9. Okay, question 10. Question 10 says f of x is x squared and g of x is that. So find f of g of 2. Okay, good. So we're going to find f of g of 2. Okay, so what you can do, what I can do, this is f of g of 2, right? So I could solve for g of 2 and then now plug g of 2 into f function, right? So you can actually work with numbers. So what's f of 2? What's g of 2? G of 2 would be 2 plus 3, right? You know, going by this. So that means that g of 2 is 5. Then I can now solve for f of g of 2, which basically means g of 2 squared, right? Going by this, of course, right? So that would be 5 squared, which gives you 25. Gives you 25. So, okay, 10 questions done. All right. So given that this is defined on the set, all right, where x is a multiple of 5, okay, find the range of f. Good. So range means range means possible y values, right? Domain, let's start with domain. Domain means x values, right? And then range means your y values, all right, for that particular function, your y values that are possible. So let's look at this. Of course, this is defining the domain. This is saying that x is between 0 and 20 and x is a multiple of 5. All right, so what are the multiples of 5 between 0 and 20? We have 0, 5, 10, 15. Now you might want to add 20, but you also need to recognize that this says 20 is not included in the domain. This just says x is less than 20. That means 20 is not included. So we just have 0, 5, 10, 15. Okay, so we can now take these values and then now check for, because we have our x values. Our x values are 0, 5, 10, and 15. So what are now the possible y values? So let's begin. If I plug in 0, what will I get for y? I'll get 1, right? So that will be 0 squared minus 0 plus 1, that's 1, right? If I plug in 5, I would have, okay, let me do the math, sorry. So f of 0, we said is going to give us 1. F of 5 would give us 25 minus 5 plus 1, 20 plus 1, which is 21. Okay, so another value we have is 21. If I plug in 10, f of 10, if I plug it in here, I would have 100 minus 10 plus 1, that should be 91. Should be 91. And finally, if I plug in 15, f of 15, it's going to give me 15 squared, that's 225 minus 15 plus 1. Shouldn't that be 211? That's 211, right? Yes, 210 plus 1, 211. Okay, so that's 211. So our range is, the correct option is option A. Okay, so again, it mostly goes back down to recognizing the idea of what this domain and range means, right? Your domain is a set of possible x values, your range is a set of possible y values. Simple as that. That's 11, so let's take 12. All right, so we have this, it says we have the function and then we're asked to find the inverse. Okay, so the inverse here, sorry, this symbol is wrong, so by the time you're watching it, obviously it would have been corrected, right? So find f inverse. Just a second. All right, so how do we do that? I'll first write the original function as y is equal to 2x minus 1 over 2 minus x, right? So that's the basic function, right? Y is equal to 2x minus 1 over 2 minus x. That's this original function here. Now to find the inverse, your job is to switch x and y, right? If I switch x and y, I would have x x is equal to 2y minus 1 over 2 minus y. Interesting, right? Yeah, so 2y minus 1 over 2 minus 1. So if I cross multiply, this, right, I would have x bracket 2 minus y is equal to 2y minus 1. I would have 2x minus yx is equal to 2y minus 1. Okay, so we're trying to make y subject of the formula, right? So if I move things around, I would have 2x plus 1. If I take the 1 over to join 2x, right, is equal to 2y plus yx. So I can now factor out y. So y bracket 2 plus x is equal to 2x plus 1. And then I can divide both sides by 2 plus x. Alright, so I would have y is equal to 2x plus 1 over 2 plus x. 2x plus 1 over 2 plus x. 2x plus 1 over 2 plus x. 2x plus 1. So that's option D. That's option D. Again, so we'll need to work on, I mean, by the time you will be saying this, it won't be a thing, but I'm just calling it out, right? What's it called? restriction here is wrong, all right? Because if I plug in -2 here, it's going to give me 2 plus 2, all right? Which is not which doesn't make the denominator 0. So the restriction here is supposed to be x plus 2, right? Anyway, but this is the correct option answer. Y is equal to 2x plus 1 over 2 plus x. Let me just check my math again. Then I switched x and y properly, I guess. X is here, 2y minus 1 minus. Yes. Then I cross multiplied, so x by that and that. Then I moved, okay, I expanded, so 2x minus yx good, 2y. Then moved 1 over, and then moved that over, and I factored out y. I had just 2 plus x left, divided both sides by 2 plus x. Yes, so it's correct. So the correct answer is y is equal to this, and the restriction is x cannot be equal to -2. Okay. So the closest option here would have been D, right? But it should have been x plus 2, not x minus 2. All right. So that's question 12. All right, so given that g of x is that, given that g of x is 3x, and f of x is cos x, find g of f of 20. So first of all, find f of 20, and then we now plug it in, right? So going by this, I can just come here. What's f of 20 going to be? F of 20 will be cos 20 in degrees, right? So make sure your calculator is in degrees, not radians. So f of 20, that'll be cos 20, which gives me 0.4, nope, 0.994. All right, so 0.994. All right, so that's f of x. You know, f of 20 is 0.94. So that means that this g of f of 20 is actually g of what? 0.94, which would be 3 times 0.94, which gives me 2.82. That's E. Okay. All right. Question 14 says, given that x is a factor of 6, is the domain of that. So domain basically represents your domain. Your domain is the set of x values, and your range is the set of y values, right? For that particular function. Okay, so your p, so this is just telling you that your domain is factors of 6. What are the factors of 6? We have 1, 2, 3, and 6. Right, so this is the factors of 6. So this is your domain. Your domain is x can only take on values of 1, 2, 3, and 6. All right, now they're asking you for what are the range, or what is the range of the function. So what are the possible y values you can get? Right, so let's plug into the function. So g of 1 would be 1 plus 3 minus 5. That should give us -1, right? So that's -1. G of 2 would be 4 plus 6 minus 5. That should give us 5. G of 3 would be 9. That's 3 squared, right? 9 plus 9 minus 5. That's 18 minus 5. That's 13. And then G of 6. G of 6 would be 36 plus 18 minus 5. This is 54 minus 5. This is 49. So simple enough, right? So -1, 5, 13, and 49. -1, 5, 13, and 49. That's option D. All right, so question 15 says find the domain. All right, so for rational functions, yes. So for rational functions, the only issue we have is when the denominator is equal to 0, right? So we just have to set it to be that the denominator can never be 0. Right, so the denominator here is 5 minus y, and we want 5 minus y to never ever equal 0, right? So that means minus y can never equal negative 5. That means y can never equal 5. So it's all real numbers, all possible numbers, except the fact that y can never equal 5. That's B. All right, 16 says, given that f of x is 2x and g of x is 3x squared, okay, find the value for which both the inverse function, find the value for which the inverse function of f is equal to the original function of g of x. Okay, that's fine. All right, so what's the inverse function? So let's do that, right? So we have y is equal to 2x. Right, so now I'm solving for the inverse function of this, right? And we know that the way we do this, we just switch x and y. So I'm going to say x must be equal to 2y. Make y subject, you get y must be equal to x over 2, right? So on this side, I just have x over 2. So where is x over 2 equal to 3x squared? That's the question we are being asked. Right? So cross multiply, you would have x is equal to 6x squared. Okay, so a lot of people make a mistake here where they divide both sides by x, and you now say, you never divide both sides by a variable because you lose one of the solutions. So I'm going to make that mistake, then I'm going to correct it. Let's say we divide both sides by x. You end up with 1 is equal to 6x, right? You end up with x is equal to 1 over 6. But that's only one of the solutions, right? That's only one of the solutions. What you should rather do is this. Instead of dividing both sides by a variable, all right, what you want to do is you get all of them on one side of the equation. So like I would have 0 is equal to 6x squared minus x. Then I'll factor out x. All right. Once you get to this point, you can use that old trick we use for quadratic, solving quadratic equations, where you say, well, if the product of these two is 0, one of them must be 0, right? So we then get x itself might be 0, which is the first factor, or 6x minus 1 could be 0. So 6x would be 1, and then x would be a sixth. Okay, so you rather go down that route than try to just divide both sides by a variable. And if you had done that, you would have gotten a solution of 1 over 6, but you probably would have been confused to say, is it A or C? All right, is it A or C? But the correct option is C. Okay, moving on. Find g of f. Okay, good. So we're given that f of x is equal to x squared, and then g of x is equal to sine x. And we're asked to find g of f of x. Right, so that means g of f of x. All right, so we just need to put f of x inside g of x, that's all, right? So that means this will be sine, and in place of x, we put f of x, right? So sine f of x, right? Or better still, sine x squared, because f of x is x squared. So the correct option is D, sine of x squared. All right, so we have, if f of x is this, find f of negative half. So we'll just plug in negative half, right? So we have f of x is equal to 10 over 2 minus x. So f of negative half would simply be 10 over what? 2 minus half, which would be 10 over 2 plus half, which is 10 over 2.5, right? So when I get to this point, I mean, again, you might be able to do mental math, use your calculator, whatever, but I could just say 10 divided by 2.5, right? Which is 10 over 1 divided by 5 over 2, which is 10 over 1 times 2 over 5. Here 1, here 2, 4. The correct answer is 4, right? 4, option D. Okay, 19. 19 says we have 4 over x minus 1. Y is equal to 4 over x minus 1. We're asked to find f inverse of 7. So we need to find f inverse first, right? So the first thing I'll do is I would say switch x and y to get the inverse function. So we have x is equal to 4 over y. X is equal to 4 over y minus 1, right? So we've already we've done the switching. So it's going to become x plus 1 is equal to 4 over y. I can flip both sides, right? You could do this, you could cross multiply, do whatever, but I could flip both sides of the equation, right? I'll be right. So that'll be y over 4 is equal to 1 over x plus 1. If I multiply both sides by 4, I would have 4 over x plus 1 is equal to y. Okay, so that's my inverse function, right? I'll just say f inverse is equal to 4 over x plus 1. Again, the process is this. You write out the original function, you switch x and y, right? Once you've done that, the y value in the switched version already represents the inverse function, right? So you just, now make that value, that y value substitute the formula. Okay, now all we have to do is plug in 7, right? So we have f inverse of 7, which would be 4 over 7 plus 1. Plug in 7 for x, we have 4 over 8, which is a pretty 1 over 2. Okay, number 20. All right, we have so we are told that y is equal to 2 tan x. Okay, now let's use f since we have two functions, right? So sorry, I thought we're doing inverse function. So f of x is equal to 2 tan x, and g of x is equal to square root of x squared plus 8. And we have to find g of f of 45. That means we need to plug in 45. We need to find f of 45 first, and then we'll now plug it into g of x, right? This is just g of f of 45. So you find f of 45, then you plug it inside, right? So f of 45, this will be 2 tan 45, right? You can use your calculator, but from special angles, know that tan 45 is 1. So this is just 2. All right, 2 times 1, which is 2. So when you say, oh, do g of f of 45, we are simply just saying do g of 2, right? Which would be square root of 2 squared plus 8, square root of 12, which we should be able to break down into what? Square root of 4 times square root of 3, which is 2 root 3, because square root of 4 is 2. All right, so that's 2 root 3, that's option A. Option D rather. Okay, we're nearly there. Let's see. G of x is that, and f of x is that. Find f of g of minus 3. So we can do g of minus 3 first, and then plug into f, right? So very easy. So let's do g of minus 3. So we'll do g of minus 3. When we get that value, we'll now put it into what? Into f. All right, so g of minus 3 here. G of minus 3 would be 2 by minus 3 plus 3. That would be minus 6 plus 3, which gives me minus 3 also, right? So g of minus 3 is minus 3. And so f of g of minus 3 just means f of what? Minus 3. So let's do that. That will be 3 by minus 3 squared minus 2 times minus 3 plus 4. Okay, minus 3 squared is 9. 9 times 3 is 27, plus 6 plus 4. So that should give me 37, positive 37. So the correct option is option A. All right, question 22 says, g of x is equal to x plus 1 over x minus 3, where x is not equal to minus 2. Again, I don't know, all this, for a lot of these questions, the the restrictions are wrong, right? So this restriction should have been x is not equal to minus 3. X is not equal to positive 3 rather. Anyway, let's find g of 2. So we're just looking for g of 2, right? So g of 2 would be 2 plus 1 over 2 minus 1, which would be 3 over minus 1, which is minus 3. Okay, that's b. Okay, so minus 3. So I'm sure by the time you're checking the question, all the restrictions would have been done. So all right, so should have been x is not equal to 3. Okay, so let's go to 23. So find the domain of this function. All right, so we have the function g of x is equal to square root of 1 minus x squared. All right, so find the domain of g of x. All right, so domain basically means, here the possible values for x, right? And we are going to have, the only issue we are going to have is that whatever is under here, okay, this guy here can never be allowed to be less than 0, because you can't take square root of a negative number. Well, you can, but you get an imaginary number which is not real, so it's not in the solution, right? So when you have a quotient, if you have p of x over q of x, all right, my restriction is that this cannot be 0 because you can't divide by 0. But if I have square root of g of x, for instance, right, my restriction is that g of x can never be allowed to be less than 1. Right, g of x can never be allowed to be less than 1. Okay, good. So we're going to say 1 minus x squared must be what? Greater than. All right, must be greater than or equal to 0. What was I saying? Sorry, g of x can never be allowed to be less than 0. Right, I don't know if I think I might have said one. G of x cannot be allowed to be less than 0. Okay, good. So we're going to have all right, so I could move x squared over, right? And I would have 1 is greater than or equal to x squared, all right? So now if it was equal to sign, it's easy to just take square root and get, because you're looking for a particular value, right? But with these guys, you have to be a bit more sensitive, all right? So there are a number of reasons around this, but I think the easiest method I would just, okay, yes, so let's just do this. So I know that if I'm solving for where x squared is equal to 1, all right, so that would be plus or minus 1, right? So I'll just draw a number line here and know that, okay, so I know that 1, negative 1, and 1, all right, are regions where x squared would actually be equal to 1. But then I would test between the solutions to see which ones satisfies it, all right, which one satisfies the relationship, all right? So there are 3 domains I have, or 3 spaces I have, right? This is space 1 where it is less than minus 1, this is space 2, and this is space 3. All right, so let's plug in. I'm going to do, for space 1 I can use minus 2, all right, and I'm saying minus 2 squared must be less than or equal to 1, right? Or 1 must be greater than or equal to 2 squared. So I'm saying that 1 must be greater than or equal to, or, which is not true, right? Which is not true. So that takes this guy out completely, right? Not possible, right? Because I tested in this area, I just picked a random value to test, and in this area minus 2 happens to be there. So that means that this area is wrong, all right? Not in domain. Because the number I picked from that space and tested did not work. Next here, I could try 0. I would say 0 squared, I would say 1 must be bigger than or equal to 0. Yes, 1 is bigger than 0, right? So this solution works, right? For this other part, I could pick what numbers reside in this third region. Maybe 5, all right, 5. So I'm saying 1 must be bigger than or equal to 5 squared. That cannot be true, right? 1 cannot be bigger than 25. So this part also does not work, all right? Not in domain. So that means that my solution is between -1 and 1, all right? And this is how we write such domains, all right? Saying that x must be bigger than, well, bigger than or equal to, in this case, -1, and x must be smaller than or equal to 1. So the correct option here is D. The correct option is D. Now, another thing you could have done is just test the values, right? Just test the values, test all the, test all the values presented, all the options. Find values in each space represented and see if they give you an actual value. All right. So this is G of R is 5 minus 2R. Find the image of that. So this is what image just means, the Y value, right? So the image of -3 is the Y value when X is -3, right? So basically this is just asking for G of -3, simple, which would just be 5 minus 2 bracket plus 3. Yes, so that'll be 5 plus 6, that'll be 11. So the correct option to this is D. Okay, 25. 25 says we should evaluate this. H of A minus H of minus A. Okay, let's dive in. All right, so what is H of A? H of A would be A cubed minus 1 over A cubed. That's simple enough. A cubed minus 1 over A cubed. Now, H of 1 over A, on the other hand, would be 1 over A cubed minus... Okay, so for this part, right, I mean, again, I'll just go and do it in the corner, right? So I want to do 1 divided by 1 over A cubed, right? I think for me, I would rather just do 1 divided by 1 over A cubed. If I write it that way, it's easier for me to process. So I have 1 divided by 1 over A cubed. That'll be 1 times A cubed over 1, which just gives me A cubed. Right, so this guy gives me A cubed on the other hand. Okay, so come back to the H of A minus H of 1 over A is simply what? A cubed minus 1 over A cubed, all of this, minus 1 over A. Hold up. Because this guy just gives me 1 over A cubed, right? So I can just write that 1 over A cubed minus A cubed. Yeah, so this is A cubed minus 1 over A cubed. Now, minus, so that'll be minus 1 over A cubed plus A cubed. So I use the minus sign to multiply into the bracket. So I would have 2A cubed minus, and when I add these two together, I have minus 2 over A cubed. Right, minus 2 over A cubed. So it's 2A cubed minus 2 over A cubed. That's option B. Okay, so let me do this tiny fraction. Let me do this here so that nobody is confused. So just in case that was an issue. So I have negative 1 over A cubed and then minus 1 over A cubed again, right? So LCM is A cubed. Divide 1 times minus 1, then do that again, minus 1, so just get minus 2 over A cubed. So that's how I got the other part there. All right, so that's B. So let's move on quickly. We have question 26. So question 26 says, find the inverse of X. Okay, good. Okay, no, find f of minus 3. Okay, so we just plug in minus 3 then, right? So that'll be 3 bracket minus 3 plus 1 over minus 3 squared minus 1. This would give me minus 9 plus 1 over 9 minus 1. Okay, for the minus 9 plus 1. Plus 1. Good. So this would give me it's 8 minus 8 over 8. Yes, minus 1. Let's see. So we have 27. 27 says we have the function, all right, defined by this. Okay, good. Let's look at this, right? So this is saying that this function, you can take a pause to listen to it if you're just watching the video on YouTube, right? But yeah, this is saying that your f of x has, this is called a piecewise function, right? It's saying that f of x has this value, where x is this, has this value when x is equal to 4, and has this value when x is this. I mean, some people write it this way. Some books will write it this way. F of x is, so then you see something like this. Is 3x plus 2 when x is greater than 4. It is 3x minus 2 when x is equal to 4, and it is 5x minus 3 when x is less than 4. Okay, so that means that if I'm looking for maybe f of 5, for instance, right? If I want to solve for the value of y when x is 5, I have to come and check here. Why am I checking here? Because, well, 5 falls into, where x is greater than 4. So there are 3 different rules for 3 selections of the domain. Okay? So you have to be careful. So for this, we have f of 4. So if I'm looking for f of 4, I have to use this, right? Because this is that. That's where I find where x is 4. So f of 4 will simply be 3 by 4 minus 2, which gives me 10. So f of 4 is 10. And then f of minus 3, I would have to use, we'll have to use the last one, right? Because minus 3 is less than 4, so it falls within this domain. So that will be 5 minus 3 minus 3, that will be minus 15 minus 3, that will be minus 18, right? So that will be minus 18. So what's the question? It's going to be f of 4 minus f of minus 3, that will be 10 minus 18, which should give me 28, positive 28. That's option A. All right. P28 says they gave the function for f and the function for g, and they say for what value of x is 3f of x equal to g of x. Okay, good. So let's do this, right? So we have 3f of x. That'll be, I'll just, so that'll be 3 times 2x squared plus 3x minus 7. That's 3f of x. So 3 times that, right? Is equal to 5x squared plus 7x minus 6. So 6x squared plus 9x minus 21 is equal to 5x squared plus 7x minus 6. So collect like terms, I have 6x squared minus 5x squared plus 9x minus 7x minus 21 plus 6. Yes. All right, it's equal to 0, right? I just moved everything to the other side, really, so I can solve a quadratic problem. So I would have x squared here from that. I would have plus 2x. And I would have 15, negative 15. Okay, so I can solve this using any method, right? I'll just use the quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Let's plug in. So x will be equal to minus b, that's minus 2 plus or minus square root of so let me just do it. A is 1, b is 2, and c is minus 15, right? If you're having issues with this, you need to go learn this. Right? So but anyway, b squared, so this will be 4 times 1, so that'll be 4 times 1 times minus 15 over 2 times 1. Just good. All right, so x would become equal to minus 2 plus or minus square root of 64 over 2, which is going to be x is equal to minus 2 plus or minus 8 over 2. So x would be minus 2 plus 8 over 2, or x is equal to minus 2 minus 8 over 2. Minus 2 plus 8 is 4, is 6. 6 divided by 2 is 3, so this is 3 or minus 5. So 3 or minus 5, 3 or that's 8. So find the domain of f, right? So when you have a square root, all right, when you have dealing with something under the square root, the issue we have with the domain is that it cannot be negative. You can't take square root of a negative number. I mean, you can, but to be imaginary, and then you have that issue, right? So we want to make sure that what we have is 4 minus 2x must not be negative, right? So it can only be greater than or equal to 0. All right, so solving this, if I take this over, I would have minus 2x is greater than or equal to minus 4. So if I divide both sides by negative 2, I would have x must be less than or equal to. So when you divide both sides or multiply both sides by a negative number, when you solve an inequality, remember to always what? Flip the sign, right? So x is less than or equal to 2. X is less than or equal to 2. That's option B. So we're nearly there. Number 30. Find f of g of 3. So we have two functions and we have to find f of g of 3. So that's f of g of 3. So I just need to find g of 3 and I plug in, right? So come here and find g of 3. He's saying g of x is equal to x minus 1. So g of 3 would be 2, right? That means this f of g of 3 I'm trying to find is literally just what? F of 2. Because g of 3 is 2, right? So we have 2 squared minus 2 minus 6. 4 minus 2 is 2. Yeah, 4 minus 2 is 2. So that would be 2 minus 6, which is negative 4. 4 minus 2 is 2 minus 6 is negative. All right, next page. So, all right. So we're given that find the inverse of the function, right? So they give us the inverse of the function, then ask us to find the original. Well, if you find the inverse of the inverse, you get the original, right? So they're both, basically inverses of each other, right? So so I have f inverse of x is equal to x plus 1 over 4. So y is equal to x plus 1 over 4. And then we switch x and y, right? So that's just the switcheroo. So we have x is equal to y plus 1 over 4. And make y subject to get 4x is equal to y plus 1. Y would be equal to 4x plus 1. So that's D, option D. We're nearly there. Number 32. I have that and that. Okay, so I have that and that. So I have f of x is equal to 3x minus 1. And then g of x is equal to 2x cubed. I'm supposed to find f of g of minus 2. So I'll just find g of minus 1 and plug in, right? So g of minus 2 would be 2 bracket minus 2 cubed. That's minus 2 times minus 2 times minus 2. That's minus 8. So 2 times minus 8. So this gives me minus 16. So this guy here is basically just asking you for, it's asking you for f of minus 16, which would be 3 bracket minus 16 minus 1. That's minus 48 minus 1, which is minus 49. Right? So minus 49. Okay, the final question, brilliant. All right, find f of g. F of g. Okay, so let's do this. So we have f of x as x squared plus 1, and g of x as x minus 2. So f of g, which is basically what? F of g of x, right? So that means we're going to be using f of x primarily, but then in place of x, we'll put g of x. So this is basically going to be f of g of x would be g of x squared plus 1. All right, in place of x, we just put g of x. So g of x squared plus 1, which is x minus 2 squared plus 1, which is, if I expand this, I would have, so let's do this here. Let's do x minus 2 by x minus 2. This would be x squared minus 2x minus 2x plus 4. So this would be x squared minus 4x plus 4. X squared minus 4x plus 4. All right, then plus 1. So I'll have x squared minus 5x plus 4. I'll have x squared rather minus 4x plus 5. Yes, so I'll have x squared minus 4x plus 5. Yay, 8. Okay, so that's the end. See you in the next video.